All right, so let's talk about the AC method for factoring. Now, this is a technique that I've noticed a lot of students can have trouble with, and it also just happens to be a technique that you encounter a lot. You're going to find a lot of problems that require the AC method. So what is it used for? The AC method is for factoring trinomials, and you should be familiar with this form, this ax squared plus bx plus c. It's for factoring trinomials where this a term up front isn't 1, right? Like here in our example, we have our front term being 6. So the AM method or sum product method, which you would have already learned by now, doesn't necessarily work. Now, I've found there are two different versions of the AC method, two different ways to actually do it. Rather than talking about both versions in one video, I've split them up. Because 90% of the people watching don't really need both methods. They just want to know the one that you talked about in class, the easiest one for factoring using this method. You don't need to know both. So what I suggest doing is, after I go through the first example, if that's not a method you recognize, go to the second video. I have it linked in the description. Okay, so let's just go through the AC method version 1 through this first example. So this is the version that I prefer, and you might have your own preference, and it's typically whichever one you learned first. So to factor this, the first thing you want to do, and the reason it's kind of called the AC method, you want to multiply this A component and bring it over to the C component. Okay? And that's going to now become x to the second plus 7x plus 12. Okay, and don't forget you put that 6 over there. We're going to need to bring it back later. All right, so from here, we want to do the AM method, the sum product method, and that should be something you're already familiar with. All right, so let's factor this, because now we have this coefficient up here being 1. We can factor this using sum products. All right, and what this version of the AC method is, it's basically sum product method with a couple extra steps at the beginning, like this, and a couple extra steps at the end to take the 6 back out. So from here, I look for two numbers that multiply to 12 and add to 7. And those numbers are positive 3 and positive 4. If you have trouble with the AM method, I have a video on that. You should check that out, because you need to be comfortable with the AM method in order to do this. So positive 4 and positive 3. Okay, now we can't just leave it like this, right? If we multiply this out, we're going to get this expression, not this one. We need to somehow put the 6 back in because we kind of took it out. How do we do that? Well, we take these two numbers and put them over 6, and we simplify as much as we can. Okay, so this 4 over 6 becomes 2 over 3. So this will become x plus 2 over 3. And this 3 over 6 becomes 1 over 2. So this will become x plus 1 over 2. Now, whatever denominators are remaining, the same way we brought the 6 over here, we need to kind of do the reverse. Bring these denominators up to the front to become coefficients. So this is going to be, the 3 will come up front here, and we'll get 3x plus 2, and this 2 will come up front here, and we'll get 2x plus 1 as our final answer. Now, like I said, if this method seems unfamiliar to you, go to the second video. All right, the version 2 uses factor by grouping as kind of the way to do AC method, whereas this version uses sum product or AM method. Okay, if this is something you recognize, let's just go to more examples. Just one thing I wanted to add before we actually get into examples is the very first step you should take. I kind of skipped this because it wasn't necessary in this particular example, but you want to factor out the common term before you actually do the AC method. So if there was a common term in all of these, you want to do GCF method first and then do AC method. And that's true for both versions, both version 1 and 2. Okay, now let's look at some examples. All right, so this first example we have is 7x to the second minus 25x minus 12. So our first step is to look to see if there are any common terms that we need to factor out. In this case, there aren't any, so we can go to step 2, the actual AC part of the AC method. We bring the A component and multiply it with our C component. Okay, so 7 times negative 12 should be negative 84. So x squared minus 25x minus 84. Now we have to do just sum product, right? We have to find a number that multiplies to negative 84 and adds to negative 25. Now these are pretty weird numbers, so let's go over kind of how to figure that out. What I like doing is typically making a table, right, off to the side. Negative 84 up top. And I just start listing different factors of negative 84 and see what works, right? Like I know positive 2 and negative 42 multiply to negative 84. However, when I add those, I get negative 40, not negative 25, right? And I could try other things, like I know 4 goes into it, so positive 4 and what else? Negative 21 would be it, which gets you not negative 25 when you add them. That's like negative 17. 3 goes into it, 3 and negative 28. Okay, 3 and negative 28. And negative 28 plus positive 3 is negative 25. So those are the numbers we're looking for. All right, so let me just kind of separate that out. So plus 3 and minus 28. Okay. Now that was the AM method, and that's put in the middle. Now just a couple of extra steps to get to our final answer. We took the 7 out. We got to put the 7 back in by creating these fractions. What we're going to then do is simplify as much as possible. So the x plus 3 over 7. 3 over 7 is already in simplest form. So that's going to stay 3 over 7. 28 over 7 should fully simplify to x minus just 4. The last step is if there are any denominators left, we got to bring them to the front. So there's nothing left here. The x minus 4 is that final term for that one. Here, the 7 goes up front, and I'm left with an 7x plus 3 times x minus 4. And that is our final answer. Okay, now let's go to another example. So this second example might use slightly larger numbers. However, the technique should still be exactly the same. What's the first thing we do? Well, we want to find the common term in everything. And it actually looks like there is something we can factor out here, 3. 3 goes into every single one of these numbers. So we factor out a 3 first, right? And we need to do that or else AC method doesn't work in either version. Okay, so we factor out a 3. And what we're left with on the inside, 42 divided by 3 is 14. X to the second. And then 51 divided by 3 is positive 17. X. And then obviously 18 divided by 3 is just 6. So that's a minus 6. Okay, so now that we've factored everything out, we want to start actually doing the AC method only with stuff on the inside. All right, so let's see here. I would have to multiply the A and C components together, so I'm going to bring this 14 over the negative 6. 3, and then it's going to be x squared plus 17x minus 84. And actually we had 84 on the last number too, so when we're doing AM method, we know that actually, let's see, what are the numbers going to end up being? We need to find numbers that multiply to negative 84, and add to negative 17. Now, I don't know them off the top of my head, so I'm going to actually start by doing my chart. Negative 84. And one number needs to be negative, and the other number needs to be positive, right? Because that's the only way you can multiply to a negative number. And we're just going to try some stuff out. So let's say negative 84 divided by 6 could work. Okay, so we'll do divided by 6 is 14. Okay, so it's going to be negative 6 and positive 14, which does not multiply to, or which does not add to positive 17. Oh wait, actually, from our last question we used, we tried 4 and negative 21. So let's try a positive 21 and a negative 4, and that adds to positive 17. Okay, so we found our two numbers. So it's going to be 3 on the outside, and then we have x plus 21 and x minus 4. Okay, now what we need to do is put our 14 back into the original expression. So I take this divided by 14, take this divided by 14, and I try to simplify as much as I possibly can. This 3 still remains on the outside. I have x plus, this will simplify to, it looks like 3 over 2, because both the numerator and the denominator are divisible by 7. This looks like the numerator and denominator are both divisible by 2, so that becomes x minus 2 over 7. Last step, I bring these up front. And I get 3 times 2x plus 3 times 7x minus 2. And that's our final answer. So hopefully this is kind of seeming a bit repetitive, a lot easier. Let's look at our next example. All right, so our next expression, 8x squared minus 12x minus 8. So hopefully these are starting to seem a bit easier to you. Let's just get into the actual steps. First thing, GCF. It looks like the thing we can take out of everything is a 4, right? 4 goes into 8, goes into negative 12, and it goes into negative 8. So I write a 4 on the outside, and what's left on the inside is a 2x squared minus 3x minus 2. Okay, and what do? I multiply my a and c components together for step 2 and rewrite my equation, 4 still on the outside, x squared minus 3x minus 4. Now, I need something that multiplies to negative 4, adds to negative 3. You could eventually find those numbers to be x minus 4 and x plus 1. Now, what do we need to do? We need to put the 2 back into our equation. So I create my fractions like this, and I simplify as much as possible. So 4 still on the outside, x minus 4 over 2 simplifies to just being 2, and this 1 over 2 can't simplify, it's already in simplest form. And what's left? Any existing denominators, I need to bring them to the front. So I'm left with 4 times x minus 2 times 2x plus 1. Simple as that. Let's just go through one last example, and then I'll just do an overview. So here we have 10x squared minus 25x minus 125. These steps should be, pretty repetitive at this point. Repetitive is good. It means you're kind of getting it. You know what to look for. First thing, GCF. It looks like 5 is the thing I can take out of everything. 10 divided by 5 is 2x squared minus 5x. And that should be 25. Yeah, minus 25. Okay. Next, let's do the actual AC method with what's left inside the parentheses. 2 goes to 25. And now I rewrite this as x squared minus 5x minus 50. So what do I have to do now? I have to figure out, okay, how do I multiply to 50, or multiply to negative 50, and add to negative 5? I think this one's actually pretty easy. Those numbers should be negative 10 and a positive 5. So x minus 10 and x plus 5. Now we simplify. Or, sorry, now we put the 2 back in, then we simplify, right? We got to put this number back into our equation. Or our expression in this case. Equations use equal signs and expressions do not. So 10 over 2 just simplifies to 5. So I'm left with an x minus 5 here. 5 over 2 is already simplified. And I have an x plus 5 over 2 here. Last step, all denominators become coefficients of the variable. And finally, I'm left with 5 times x minus 5 times 2x plus 5. All right, so just to review, AC method, it's going to come up a lot, but really it's just a set of steps to kind of get in your head, right? Step 1, GCF, factor out all common terms. Step 2, multiply your A term to your C term. The reason it's called AC method. Step 3 would just be to factor using sum product. Step 4, you need to put your old A term back into the equation by creating these fractions. Then you simplify those fractions. The last step involves taking the denominators of those fractions, bringing it to the front of your equation, and then you'll have your final answer. All right, so hopefully I made AC method seem a bit easier. If you have any questions, throw it down in the comments. But other than that, that's pretty much it.